Hi, we have already seen factorization by the method of common factors and factorization by regrouping terms, right? In this video, we will learn a new method that is factorization using algebraic identities, right? So, factorization means writing an algebraic expression as a product of simpler expressions, right? And one of the fastest ways to do this is by using algebraic identities. Let us quickly revise the most common identities. The first one is square of a sum, where a plus b whole square is equal to a square plus 2ab plus b square, right? Then we have square of a difference, where a minus b whole square is equal to a square minus 2ab plus b square. And then we have difference of squares, that is a plus b multiplied by a minus b is equal to a square minus b square. Okay, so I will give you links to these identities in the description in case you want a quick refresh. So there are more identities, but for now let us focus only on these three. When we see an expression, we observe it carefully and try to match it with one of these identities, right? And sometimes we need to do a little calculation to check if it fits. Okay, so once we identify the correct pattern, we can write its factorization form. Let us understand this by an example. We will follow these steps. So step number 1 is observe the expression. Then we will identify the identity to see if the expression has a form that fits the right hand side of the identities, right? So we need to see this expression, that is y square plus 10y plus 25, fits in which of these identities, right? So we will see right hand side of the identity, that is a square minus 2ab plus b square, or a square minus b square, or a square plus 2ab plus b square, and try to figure out y square plus 10y plus 25 fits in which of these identities, right? We will look at the right hand side of all of these identities to identify where exactly this expression fits. Okay, and once we identify the identity, then we need to write the factorized form. So if the expression has a form that fits the right hand side of one of the identities, then the expression corresponding to the left hand side of the identity gives the desired factorization, right? Say for example, y square plus 10y plus 25 fits in this kind of format, that is square of a sum. So the factorization is going to be its left hand side of the identity, that is a plus b whole square, right? Okay, let us see this example. In this example, we are factorizing y square plus 10y plus 25. Okay, let us solve this example. Our first step is to observe the expression, right? So if you look this expression, I have 1, 2 and 3, that is 3 terms, right? So there are 3 terms in this expression. So identity 3, that is difference of squares, does not apply in this example because in difference of squares we have only 2 terms, right? So this will not apply. Now the first term is y square, right? So y square is a perfect square. So y square is y multiplied by y, right? And the last term, that is 25, is, I will write it at bottom. 25 is also a perfect square of 5. So 5 multiplied by 5 is 25, right? Or 5 to the power 2 is 25. Okay, and the middle term, that is 10y, I will write 10y is equal to, this is twice the product of y and 5, right? So 2 multiplied by y multiplied by 5 is 10y, right? Now for the step 2, we need to identify the identity. Okay, here notice that its first and third terms are perfect squares, right? And middle term is positive, it's plus 10y, right? So this matches the square of a sum. So this expression is in the form of a square plus 2ab plus b square, right? Where a is equal to y and b is equal to 5, right? So we can say that this expression is in the form of a square plus 2ab plus b square, right? I will write it down y square, our expression, plus 10y plus 25. Both have the similar format, right? Or 25 I can write it as 5 square, right? So this is y square plus 10y plus 5 square, right? Now for the third step, I need to write its factorized form. So you have seen that a square plus 2ab plus b square is nothing but a plus b whole square, right? So this is a plus b whole square, right? So y square plus 10y plus 5 square is going to be y plus 5 whole square, right? Where y is a and 5 is b. This is what we have seen. Y is a and 5 is b, or a is y, b is 5, right? So this is the answer, y plus 5 whole square. Okay. Now I will give you one example. You try to solve it on your own, right? So this is the example. Try to solve it. X square plus 14x plus 49, right? You try to solve this example and write your answer in the comments. Okay, so here are a few quick tips to identify patterns. So the first is three term expressions. So we need to check if the first and last terms are perfect squares, right? Then for the middle term, is it twice the product of square roots of the first and last term, right? And if this is yes, then any of these two identities we need to follow. Okay, either a plus b whole square or a minus b whole square, right? And then we need to see the two term expressions, right? If it looks like a difference of squares, use the difference of square identity. Okay, I hope you understood this concept. In my next video, I will continue this lesson and see examples of how to identify squares of a difference. This example we will see in my next video, right? Thank you for watching.